Hello, seniors. Continuing with electronic assignment number 3. Remember, I posted 2 videos earlier last week for part 1, where we saw the definitions of secant line, tangent line, normal line, and we did also a definition for the derivative of a function, right? We talked about the derivative of a function being the gradient or slope function of a tangent line to a curve at a given point. And we've seen the definition using the concept of limits, right? We did that in the first class. In part 2 of this class, we have seen more examples about the definition of derivatives, and then we've seen an abbreviated or a shortcut to finding the derivative of a function, of any type of function, which is x to the power of n, right? So we've seen this power rule, and we said that if a function was x to the power of n, where n could be any exponent, then its derivative function would be equal to n. We remember the rule. We take the exponent down here, and then the exponent decreases by 1, right? So if f of x is x to the power of n, then the gradient function is n times x to the power of n minus 1, where n is a real number, right? And we've seen 3 basic examples to start understanding this. For example, x to the power of 12. If the function is x to the power of 12, then its derivative function would be 12. We take it down to the front, and the exponent is decreases in 1, so it stays as 11. So the derivative function in this case is 12 times x to the power of 11. And then we saw different cases in which before actually doing the power rule, we had to take the exponent up in this case, because remember, this rule applies whenever the x is in the numerator, not in the denominator. Okay, so we had to do this first and then apply the power rule in order to find the gradient function. And when we had radicals, we first wrote the radical in its exponent form, and then we applied the power rule, okay? So those were 3 basic examples of how to find the derivative of a function. So to finish this electronic assignment, we're going to see part 3. We're going to get into more difficult examples about the power rule, and we're going to see some properties of differentiation. So what is differentiation? It says it's the process of finding the derivative of a function. So it's almost like a synonym for derivative, right? If you read the word differentiate the following equation or the following function, it means that you need to find the derivative of that function, okay? That's what the word differentiate is. So here are some properties about differentiation, which we're going to be covering a lot in the following classes. But just for you to start understanding this, it says the constant rule first. If f of x is c, where c is any real number, then its derivative or its differentiation is equal to 0, right? For example, if f of x is equal to, let's say, 3, that's a horizontal line, right? A horizontal line at y equals 3. And if you analyze the horizontal line, its slope is always 0, right? So whenever we have a constant number and there's no x here, you can think about having something like this, right? 3 times x to the power of 0, right? And if I differentiate this, if I find its derivative, so f prime of x would be, we follow the power rule and we take the 0 multiplying down here, and 3 times 0 is exactly 0, right? To the times x to the power of -1 would be, right? But as we have 0 here, the derivative is just 0, right? 0 times anything is still 0, or 0 divided by anything is still 0. That's why the derivative of any constant number is always equal to 0, okay? So that's the first rule, constant rule. Then here it says the derivative of any constant is 0. The graph of the constant function f of x equals c is a horizontal line which has a gradient 0. Okay, that's what I just explained. Then it says constant multiple rule. If y equals cf, where cf of x, where c is any real number, then the derivative function is c times f prime of x. This is just saying that if, for example, I define f of x as whatever, let's say it's x squared. If I multiply this function by a constant number, let's say, for example, 4f of x. 4f of x, this would be equal to 4x squared, right? And if I find let me find the derivative of the first case, f prime of x. In this case, the derivative would be, we take the 2 down here, so it's 2x to the power of 1, right? 2x to the power of 1 is just the same as saying 2x. And here, if I'm going to show you this. I'm going to do it. If I multiply this by 4, we would say that 4f prime of x would be equal to 4 times 2, that's 8x, right? 4 times 2, 8. And if I find the derivative of this, of 4f prime of x, let me do that. Like this. If I find the gradient of this, I take the 2 down here. 2 times 4, that's 8. So you see that we get the same result, right? 8x, and here 8x. So what this rule is saying is this. The derivative of a constant times a function is a constant times the derivative of the function. That means that we can just ignore the constant number, and find the gradient function, and then multiply that constant number to the gradient function, right? That is what we're saying with that property. Finally, we have the sum or difference rule, which says if f of x equals ux, or one function, plus or minus another function, vx, then the gradient function of f would be the gradient function of u plus or minus the gradient function of v. Okay, so if, for example, I say that f of x equals, let's say, x squared plus 4x cubed. Okay, so we say that this function over here is ux, for example, plus another function, this one over here, which we're going to call vx. So if I want to find the slope or the gradient function of f of x, what I'm going to do is just differentiate this separately, and that would be the result, okay? So the derivative of x squared is 2x. By following the rule, I take the 2 in front, and the exponent decreases by 1, so 2x. And the derivative of 4x cubed would be, I take the 3 down here, 3 times 4, that's 12. 12x, and the exponent decreases by 1, so this is 12x squared, okay? And this would be the gradient function for f of x, okay? I just differentiate u and x and v separately, okay? So those are the three properties you should understand, right? The constant rule, the constant multiple rule, and the sum or difference rule. Okay, finally, we're going to see some examples to ground all of these concepts, and you'll see that this is quite easy. So it says differentiate each function. Differentiate means find the derivative of each function, right? So for part A, f prime of x, the derivative would be, in this case I can differentiate directly, right? And we're going to use the sum or difference property in order to differentiate this separately, right? I'm going to differentiate this term, then this term, and finally this term. So the derivative of 4x cubed, that would be, let me do step by step. It's 3 times 4, we take the exponent down, times x, and the exponent decreases, so it's to the power of 3 minus 1. I'm going to show all the steps here. Plus, in the second case, this is 2 times 2. The exponent goes down. X to the power of 2 minus 1. Okay? And finally, we have a number, a constant here, minus 3. So remember that the derivative of a constant number is always 0, right? So we're going to write this. If you want, you can write this as x to the power of 0, and you'll realize that when you take this down, you're going to have 3 times 0, which is 0, right? I can write that here, but you don't need to. But as I'm showing all the steps, this is plus 3 times 0 times x to the power of 0 minus 1, right? So finally, if I reorganize all of this, this would be 12x squared plus 4x plus 0. Okay? So I don't even need to write the plus 0. The answer would just be 12x squared plus 4x. And this is the derivative of part A. Okay? You see that this will become very mechanical and very easy as you practice this. And you see this is not difficult at all. Okay, so let's see part B. In this case, f of x is 3 times the root with radical 5 of x plus 8. So the first thing I want to do here, in order to apply the power rule, is rewrite this radical using exponents, right? So we're going to say that f of x, that's an ugly f of x would be equal to 3 times x to the power of 1/5, right? That is the exponent form of this radical, plus 8. Once I have done this, then I can do the power rule and find the differentiation or derivative of f of x. So this would be 3 times the exponent, which is taken down, 1/5, times x to the power of 1/5 minus 1, right? And the derivative of 8, which is a constant number, is, as you already should know, 0, right? Plus 0. So then I need to subtract this. 1/5 minus 1, that's negative 4/5. So f prime of x is equal to 3 times 1/5, that's 3 over 5. 3 over 5 times x to the power of negative 4/5, right? And plus 0, I don't need to write this anymore. So if I want to write this in a more elegant way, I would say that this is equal to 3 over 5 times the 5th root of x to the power of 4. And I'm writing this in the denominator because the exponent is negative, right? So this would be the derivative or differentiation of the function in part B. Okay, so that's the answer. Then we have part C. I'm going to write the function. Part C, we have this function f of x equals x minus 2 times x plus 4. Okay, how am I going to find the derivative of this function in this case? You see that here we have a product of two binomials, right? And we still haven't seen how to find the derivative of a product between two binomials. So what I need to do in order to avoid having to differentiate a product, which we don't know yet how to do, what I can do is I can distribute this, right? I can do a FOIL method and expand this expression and then see what happens. So if I expand this expression, this would be equal to x squared plus 4x minus 2x minus 8, right? And if I add like terms, this would be x squared plus 2x minus 8. And this is an expression that I know how to differentiate, right? If I find f prime of x, the derivative of f of x, this would be equal to 2x to the power of 1, right? Because the exponent decreases by 1. And if I differentiate this, how do I differentiate this? 2x. You see that this is to the power of 1, right? If I take the 1 multiplying down here, it's 2 times 1. 2 times 1, which is 2, plus 2. And this x becomes x to the power of 0, right? 1 minus 1 is 0. So x to the power of 0 is actually 1. So this just stays as 2, right? And the derivative of a constant number is always 0, right? So plus 0. So f prime of x, the derivative is 2x plus 2. That's the derivative in this case. Okay? Finally, if we go to exercise D, let me copy the function first. It says f of x equals 4x cubed plus 2x squared minus 3 divided by x. Okay, how am I gonna differentiate this? As in this case, we still haven't seen a rule for the derivative of a division between two functions, right? I don't know how to differentiate a function divided by another one. In this case, we can say that this is, that this is ux and that this is vx. But we still do not know the rule of how to differentiate the division between two functions. We're going to see that later on. So if I don't know, I need to see the way I can simplify this. Since this x is dividing the three terms, right? I can separate those three terms and rewrite this function as 4x cubed divided by x plus 2x squared divided by x minus 3 divided by x, right? And I can simplify each of these terms. For example, in the first case, x goes with this cube and becomes squared. This one eliminates with this one and we get 1. And 3 over x, I'm going to take the x up in order to have it in the numerator and be able to differentiate. So if I rewrite this expression, this would be 4x squared plus 2x minus 3 times x to the power of negative 1. And now I know how to differentiate this, right? If I want to find f prime of x, this would be equal to the derivative of 4x squared. That would be 4 times 2, that's 8 times x to the power of 1, right? There's no need to write to the power of 1, so you could leave it like that or just erase the power of 1. Plus the derivative of 2x to the power of 1 would be, right? So 2 times 1, that's 2 times x to the power of 0, which is 1, right? So I don't need to, so this is 1 minus 1, so it becomes x to the power of 0. So x to the power of 0 is 1, so I don't need to write that anymore. So plus 2, and in this case, negative 1 goes multiplying in front. Negative 1 times negative 3, that's positive 3, so plus 3. X to the power of negative 1 minus 1, that's negative 2, right? So this would be the answer. If I want to write this in a more elegant way, I could write this as 8x plus 2 plus 3 over x squared. And this would be the gradient function or derivative in this case. Okay? And that will be it, seniors. I think this is clear enough. If not, please let me know. We can clear these doubts in the in a live session. But you see that as you practice with these rules, you see that it is very easy to find the gradient function or derivative of a function. Okay? So, that's it, seniors, for this class. I hope this was clear. If not, please let me know. See you.